上在上面协作的话，都是会两个学生左右。那2个学生4点其实已经做出有对，就1人1点嘛。那如果是4点，就是1人2点。对，目前是2点。对。这要 upgrade， 拿回原厂，对，就是拿回原厂。对 upgrade， 对，到时候可能会有另外价钱。对，但是在神仙有就可以。目前计划是可以这样子的，但是我们要看到时候 SKT 来的时候，有可能这是对就可以实现，对，这是有可能。我们3月初的时候就会知道整个流程。我们2月13从中国寄过来。一样3月初。对，3月初对。好。周日，以下你自己一个人下来是吗？对。
Hello。
对。
Hello。
对 ，MSR 平台，对，当然，对，可以说这样。OK。对，好。对。对。对，好，这我们如果要聊人来的时候。
OK。
但是我会建议的话是下礼拜25号结婚。
Hi, I am the TA, and I came here to help you to deal with some basic algebra things. This is today's class is the first class. So our purpose for basic algebra is to help you to understand the fundamental of the expressions, the equations, and the functions. Okay.
现在是2月11号，下礼拜。你下礼拜你觉得哪一个时间是最好的
？First, let's think about what are the expressions. Expressions and what is equations?
就是这个价钱是要给这个解决对的价。
And what is functions?
OK， 再有一个名的，然后我们直接 MSRP 跟大概的价格认识。
Okay. Before we continue, let's think about what are the difference between these three things. Actually, I know some of you have already seen these three expressions quite a lot. Expressions, equations, and functions. And second, we are going to figure out the relationship and the difference between these three things. And also, finally, we are going to try to find a way to solve some question related to the functions. Actually, there is a logic that between the things.
我这边先试一下。好，试了先。
它里面只是你想看的。
不是我想看的。
你想象里面包的，
不知道啊，试试看，试试看之类。
台湾有的是包，
啊，是糖的。
台湾那是包甜的，这日本的包咸
甜的？
咸的啊，
马蹄到底是什么东西？它是什么味道？
糯米
敲的，把它敲怎么在操死？
那你有橘子啊，你也可以做。真的，
你现在有比赛啊？我觉得比赛还可以，那喉咙痛头痛真的是。
现在那个鼻子，
我现在发现真的就是感冒，因为你也治不好，就关键就是要把症状给压下去，去买那种药，就专门治这种东西。像我上一次头疼，我现在就吃那种就是像 pain relief， 就是专门那个吃的时候吃。我今天我稍微吃了一点，因为今天早上起来头疼，但是前2天没有头疼。热汤没有。
主要那天就是看把他那个 partner 带过来，然后那个 partner 是有感兴趣。好啊，那我们就约。
And our target is to know the definition of the expressions, equations, and functions, and figure out the logic relation between the three content, and also later we will try to know how to solve problems related to the three content, especially for functions. Okay. So first of all, why we need to understand expressions, equations, and functions? Because there is a logic relation between these three things. Expressions are the component of the equations. So this is the logic thing. The logic behind them is that the element. And say, if you have an equation, actually you have already represent a relationship between left hand side and the right hand side. They have a relationship. So if you want to talk about a function, function is also talking something about the relationship. And actually when we're talking about a function, we are talking about the relation between one variable and another variable. And sometimes we also rewrite this variable as fx, which is called the function of this variable x. So they have a relationship between these three content, which is expression is the element or are the elements of the equations. And the equation give us a relationship, and if we are talking about two variables and they can represent using equations, we call them functions. So this is the first logic that behind these three comments. And the next we are going to say that, okay, our final purpose for this chapter is to understand the functions. And we will know that actually function can also represent by rather than word, by a table, or by a graph. This is our purpose, to understand that the function can be rewrite or represented by so many ways, and also using the function we can solve quite a lot of questions. So this is a basic idea and our final goal for this chapter. Finally, we will understand what function can help us. Okay, next page. First, let me show you some examples about what are expressions, what are equations, and what are functions, so that you have a general idea about that. And I know most of you have already seen this kind of expression, so I just want to show you. If I write x, of course this is called an expression. And what about x minus 1? If we have a variable and also with a constant and we use operator to connect them, this is also called an expression. Oops.
在直播。
对，现在在用 YouTube 直播，你先去看一下，这是应该是现在已经成功了。如果成功的话，我再从头开始。我先试讲一遍。And also, if we want to talk something more complex, like x squared, okay, although this is kind of like a little bit different from what we read before, but this is also called an expression, and the operator we use here, which is the power of 2. Yes, the square, use the power of 2. And the same thing, if we use the power of the fraction number, like 1/2, also we can call it an expression, and this is square root of x. Okay, so no matter for the first one, the only variable or the very complex expression here, we all call them expressions. Okay. Any questions about the expression? No. Okay, next one is we were talking about the equations. Okay, just like we said before, the equations are made up by the expression. So just like something x equal exactly a number, this is called an equation, of course. And the same thing like x minus 1, the left-hand side is an expression and the right-hand side is a constant number. This is also called equation. And even more complicated, just like x squared, and this time we will use another variable rather than x. Maybe we can use z to represent our equation. The cube equals 1. This is also an equation. So right now we can see the equation and expression, the only difference between them is that there is an equal sign here. And no matter for the left-hand side or the right-hand side, it can be an expression or a constant, or maybe both hand side could be an expression. So this is called equation. And just like I said, equation gives us a relationship between two expressions or maybe several expressions. And the next part is if we have two variables and we want to connect two variables together with some relations, now we create something called function. And just like y is an expression, right? And we write it on the left-hand side of the equation. And the right-hand side of the equation, we use another variable, maybe x squared. And this is something called function. And we also say that y is a variable that will vary by x changes. So this equation can also be written as a function form. Fx equals x squared. So this is how function tells us. Any questions for the expression, equation, and functions right now? These are the examples for them. Okay, next. Let's go to a new page. So, next part is who use expressions. Let's go to expressions and teach to talk deep. Who use expressions? Actually, expression is the basic element in the math world, which means that it is a math language. So everybody that in the world, if you use expression to tell them, which means that they will understand no matter they speak English, they speak Spanish, they speak Mandarin. If you use expression, everybody in the math world, we will use expression as our basic component of the language. And just like the real language, for the real language, we will have verb and a noun. And just like we will use a verb to connect different nouns together. So for the expressions, we also have verb and a noun that respectively. So for the noun, we just introduce a variable, what we said before. What is a variable? Variable is something like x, something like y. This kind of alphabet letters. This is what we call variable, and we use variable to represent that the number that we don't know, or there is a list of numbers that we don't want to list all of them. Now we will use variables. And what are verbs? Verbs will connect all the nouns together in other language. So in expressions, we have operators. And if you have operators just like plus, minus, times, divide, and even just like square or square root, no matter for these kind of operators, once they can connect the different variable and constant together, we call them operators. So if I want to connect x and y together, I can use plus or minus. So this is an expression. What about this one? X squared, just like I said, x squared is also expression because we use the power operator to connect x and the constant 2 together. So these are all the operators. And the operator are exactly the verb that connect the different variables, just like nouns that in our math language. So this is what we called expression, and why we need to learn expression is because expression can give us a universal way to illustrate what we want to represent. And okay, in our elementary school, actually, we have already learned a lot of expressions, but at that time, we are not using variables. We are using constant. Do you still remember? Okay, let me show you some example so that you have a review of the expressions with constant. So let me give you an example. If the salary rate, which is like $9.15 per hour, and you work about 8 hours per day, and maybe your boss want to ask you, okay, how much money that you will make that during one day. So in this case, what we will use? We will use 9.15, which is our salary rate, and times the hour that the number of hours that we work, which is 8 hours. Actually, this is exactly an expression, but for this expression, there is no variable in it. We just have constant. And the same thing, this is exactly what your boss said for work for one day. What if the boss wants to ask you, okay, if you work for about 20 days per month, and totally you work 12 months, For this one, this expression, yes, this is also expression, and this expression can give us how much money you will earn for 1 year. Now comes the question. What if I want to know the money that you make using different times? Just like maybe I want to know what's the money that I
我直接直播了，直接从这里开始。
直接从这边开始，那我可以
还是
退到
你要重新
前面去，可以退到前面去。
他会重新的。
对，
那我现在从
直接好，行，
你直接，你继续直播哈，然后我直接就打到 Facebook 上面去。
可以可以。
啊，
你现在已经看到我了是吧？
对，我有看到你。那你先等一下就从直播，然后我等一下出来，我如果放到 Facebook， 我会跟你讲 OK， 我就出来了，好，然后我就开始投。
好，就看有多少人是的。
等我一下啊。
好，没关系。那你有，我怎么看那些人给我的评论？我需要一个电脑来那个，去监控一下是不是？这一台，直接就竖在这个地方。
你要连哪边？
就随便就放在这个地方好了。反正我现在只需要知道内容，只需要知道他们有没有回馈。
我已经转到那个 Facebook 了。
好的，那我要开始讲了，对吧？
那你慢慢来，等一下。
我电脑还没开呢，对，我电脑 Surface 还没开。
怎么了？
怎么这个 filter 点不出来呀？奇怪。点出来了。你已经开始放广告了吗？
还没有，等我一下，我先把这个。
好的。现在2个 watching， 说明没有新的人进来。就一个是这一台，一个是那个台。
他说的 site cannot be reached。
什么意思？
我在日本等到这个视频。
为什么
所以，但是现在是有。
他两个人那个连接方对不对？
如果点的话，如果在这边点的时候就。
这个链接是手机。是完成分享，
你给我的那个，
分享这个完成。
那我直接开始推广了。那我发到我个人的。好，可以。
我把它开始进。
好，你有看到那个吗？
我要看什么东西？
啊？
要正式了吗？
好，我现在开始讲了。
好。
我现在这边上面显示一个人都不在看，一个人在看。
OK。
Hi everybody, my name is Yuan, and I will be your math TA for every weekend. And today we were talking about some basic content in basic algebra. So let's start our today's teaching. And if you have any questions, you can talk in the live chat, and I will check that regularly, like in about every 10 or 5 minutes, and so that if you have any questions, I can tell you. Okay. So today our purpose is to talking about something about the expressions, equations, and functions in a basic algebra. So first, let's say we were talking about something about expression, equation, and function. Okay. The purpose for this chapter, actually, finally, we want to know why we need function and how can we solve some kind of questions that using functions. This is our final purpose. And why we just need the function, but we have to learn the expression and equation. Actually, there is a logic that behind this. So first, let's talk about what are the difference between these three contents and what are the relationship between them. Okay, every time when we're talking about expression, actually expression is just the elements of the equation. So different equations will finally construct or made up to an equation. And we can also say that the equation is made up from the expressions and also the equal sign. So this is what we call it. Expression will make up equations. And when we know the equation gives us the relationship of the equal relationship between different expressions. And what are the relationship between the equation and function? Actually, when we're talking about the equation, we are talking about two different expressions. And sometimes the expression will contain something called variables. And for function, that is a good relationship between one variable and another variable. So function is a specific equation, or sometimes the function cannot be equation, but for most of the case, function is a specific equation. So that's why we will say that function is a subset of some kind of equations. So these are the logic that between expression, equation, and functions. Right now, any questions for this? Okay, so if we do not have any questions, let's go and continue talking about the basic thing about the equations. Okay, for our final purpose, which is to understand why we need functions, but first, let's talking about if we have already know the functions, what kind of thing that we can do to that? Function give us a good way to represent the relationship between two variables, and the two variables can also be different numbers that in the real world. So function is a good method help us to solve questions. And also later after this chapter we were talking about if we are talking about function, there are so many ways to represent that. We can use tables, we can use lists, we can use even graph, and also the most intuitive way, we can use words to represent different functions. So function is a pretty good method help us to represent the relationship between two things. And these kind of table, list, graph, and words, they are a good represent way help us to represent the function. This is the idea. So any questions about the functions here? And this is our final goal, to use different methods to illustrate the function, and also our goal is to use these kind of expressions and use the function help us to solve some question, to solve some real problem. Okay, so it seems like there is no question, so let's go and continue. Okay, so let's go back to expression. Actually, we have already seen a lot of expressions, equations, and functions. So let me first show you some examples about the expressions. Okay, in our primary school, actually maybe you have already seen, if I have an x, which is an unknown number, and this unknown number, we call it a variable. This is exactly an equation, and the easiest equation. There is only one letter in that. And also, if you want to say that there is not just one variable, maybe we want to have some constant connected with the variable, just like x minus 1. Can we say that is also expression? Yes, of course. This is something that we have a variable and subtract 1, which is one amount less than this variable. This is also expression to talking about something else. And what about, I don't want to use plus, minus, subtract, something like that. I want to use more complicated operators. Is that possible? Yes, just like x squared. This is also an expression. And just like we see here, although there is a square, but we can still regard this as an expression, but more complicated. And the same thing, if you can say x to the power of 2, can we say x to the power of 1/2? And what is x to the 1/2? Exactly, square root. So square root of x is also expression. So all of these examples, we all call them expressions. And next I want to show you some examples about the okay, sorry about that. This is a technical problem, but it's okay. Okay, so this is square root of x. Next, I want to show you some example about the equations. Just like I said, equation are expression and expression, connect them together with an equal sign. So let's assume the left-hand side is x. The right-hand side is another expression just like x squared minus 2x plus 1. Yeah, maybe this is also expression. And when we connect two expressions, use an equal sign. When we write something like that, this is called equation. And the same thing, if I want to write like let me try to use another letter, use z. Z squared equals, and this time I don't want to write variables anymore. I just want to write a constant like 8. Is that okay? Of course okay. This is also called equations. So as we can see here, the example for the equations are just the different expressions and connect them together, use an equal sign. Any questions? Okay. Next part is the example for functions. Functions are special equations. Actually, they are talking about two different variables connect together, and the function will give us a relationship between two different variables. So no matter for this equation or this equation, there are just one variables. For this one, there are just x variable. For this one, there are just z variable. What if I want to know the relationship between z and x? I will have a function. So what if I said z equals x plus 1? In this case, actually, this is what we can call a function. And for formal function form, sometimes we may not just using z, we will write fx, which represent this is the function of x equal the x can write in this format. So this is the relation between two variables, and if you want to just emphasize or focus that this is the function of the variable x, we can write in this way. So these are the difference between expressions, equations, and functions. Any question? If you have question, you can write some comment on the live chat so that I can see you. Okay. Let's go to the next part. If there is no question, let's talking about go back to expressions. Who speaks expressions? Actually, everybody in the math world will speak this language. So just like regular language, we will have verbs. Let's change the color to make that cheerful. Okay, orange. Okay, in the regular language, we will have verb and noun. And just like we say that verb will be a connection between different nouns in languages, just like I eat something, right? I eat something. Okay, in this sentence, just like you say, I and something are the noun, and the eat are the connection, right? The verb that connect the different nouns. Exactly in the math word, what are the nouns? We just show you the nouns are exactly variables. X is a variable. Y is a variable. And all these things we could say that they are nouns and expression. And what are verbs? And we will introduce operators. And operator, actually, I just said that in the previous class. Operator, no matter plus, minus, times, divide, all these we call them operators. We can use this operator to connect the different variables. And also, there are some complex, which is power and square root, and square root 3, power 3, something like that. These are all called operators. So, if we want to write an expression, we can use operators to connect different variables. This is the idea of expression. Expression is another language, but this language will be understood by everybody who is in the math world. That's why we introduce expressions. Okay, next one is, if we have already known the operator and the variables, have we ever seen expression before in our previous class? Actually, yes. In elementary school, actually, we have already know quite a lot of things about expressions. But at that time, maybe we are not using variables. We are just using numbers, and which is we call right now called constant. So let me give you an example. Let's talk about if the California salary rate is $9.15 per hour, and you work about 8 hours per day. Can we say this is expression? Of course this is expression, but this expression is a little bit different from what we said before because there is no unknown number, there is no variable in it. We just have constant number, which is a salary rate and the working hour. What if your boss said that, okay, maybe I don't want to know the money you make for one day because I need to pay you for about 1 year? What about if you work about 1,950 hours per year, how many money you will make? This is exactly the money that you will make. So is this also expression? Of course, this is expression. And here comes a question. If your boss do not want to know 8 hours, do not want to know 1,950 hours, he just want to know some other numbers just like 1, 2, 3, 4, etc. And maybe he also want to know something like 3.5 hours. If you work about 3.5 hours, how much money I need to give you, I need to pay you. So in this case, do I need to write a list of all the expression to illustrate how much money you will make? Of course, we cannot write an infinity list or infinity table of all the salary expressions. In that case, that's why we introduce variables. If we assume, okay, let me give you a new page. If we assume 9.15 is the rate, of course, salary rate. It won't be changed if you are just a basic worker or just a basic teaching assistant. This is the rate that it won't change. But if we assume that the hours that the time that you work, we can use t to represent, and t is what we call the variable before, right? T is a variable. In this case, can we use the expression to illustrate the money that you make if you work t hours? Of course, we can do that. 9.15 times t. And for some conventions, actually, times we can write using a dot to simplify that. And sometimes that for more even simplification case, we can ignore the point, which is 1.95 t. These three expressions are exactly mean the same thing that in the math world. So later we will just use this one to simplify our expression. But no matter for what, now we understand why we need an expression, because we cannot write every single combination of the list or the table that's the hour that you work for. But if you just assume the time that you work is exactly the variable t, we can use the expression 9.15 t to illustrate the money that you will make, and no matter what kind of t that you work, because t may be 0. If you do not work any time, you will earn 0 money. That makes sense, right? So expression can even give us some extreme case. So this is exactly why we need expression and why we teach you the variable to represent the expression. Any questions for that? Okay, this is a pretty easy question, pretty easy example, right? Okay. Once we know the expressions, and there are some there are some pretty important rules for these expressions. And because we know that we can use different operators, so also for some regular constant expression rules, we also have that for variable rules. The first is x plus y equals y plus x. This is for sure. This is true. No matter for variables or constants, this rule will always be true. So the same thing for the minus. X subtract y equals y subtract x. No, that is not true. But we can have some chance. X subtract y will equal to y subtract x, but there is a minus sign that's before that. So this is what we're talking about, the very first basic rule. And second, if we are talking about times, x times y will equal to y times x. Okay, this is a pretty important rule because we can write in both ways. So for most regulation or for most conventions, we always want to write it alphabetically because we can write it in both ways. And also, beside that, there is some other rule called association rule. X plus y equals, association rule, we at least need three variables. X plus y plus c will equal to x plus y and z. So if we add the last second two together, this will be the same result. Same thing for the multiplication. X times y times z will equal to x times y and z times together first. This is called association rule. And if we know the plus and multiplication, actually there is a combination rule that for them, which is called the distributive rule. Okay, let me eliminate this part. Okay, I hope everybody have already know this part, right? Okay, so what is distributive rule? Distributive rule is something like x times y plus d. In this case, we can distribute x to different numbers so that it will equal to x times y plus x times z, and this is called the distributive rule, and this is exactly the same as constant number expressions that we learn in elementary school, but right now we are just using variables. Any questions for this? Okay, if we do not have questions, let me give you new examples so that to make sure that we understand the expression pretty good. So let's assume there is a car and a driving speed, which is we will use variable c to represent, and the traveling time, which is t. Okay. So in this case, I want to know the distance that this car drives if it will always follow the same speed constant c, the same constant speed c, and travel about t times how long I will drive. Actually, this is a pretty easy question because we just need to use c times t, use this expression to help us to illustrate, okay, this is exactly the distance that they drive. So now you understand why we need to run expression. Because for expression, you don't need to write a list, and maybe this list is an infinity list, and maybe, okay, my driving speed is 60 miles per hour and I drive about 2 hours. My driving speed is 60 miles per hour, I drive about 3 hours. Maybe I drive 3.5 hours. Maybe I drive 4 hours. Maybe my driving speed is 70 and my driving time is 1 hour. There are so many combinations. There are infinity combinations. We don't need to use a table to represent. We just need to use CT. So this is the advantage why we need to learn expressions using the variables. Any questions for this? Okay. So because we have already totally understand the expressions and the variables, so let's go continue to talking about the equations. Okay, actually we have already teach some equations here. If I just write an equal sign for distance and CT, actually you have already seen there is an equation. And later we will introduce some more equations. Let's go continue. Okay. So this time, let's talking about a geometric problem. If I have a rectangle, yeah, and for everybody, we have already know this is called length, this is called width, and also maybe we can do that inversely. So doesn't matter. Let's assume this is the length L, this is the width W, and I want to calculate the parameter of that. Is there a way that we can write an expression for that? Okay, let's think about how to calculate the parameter. Do I need to use length plus width? And we just get the half of the parameter, right? And what about the other half? Is there another way to do that? Because we know for the rectangle, this part is also L, and this part is W. So there is a pretty easy way to write the expressions, which is length plus width plus length plus width. Yeah, this is done. This is exactly the expression for the parameter. And let's think about, it seems like too long for me. And do we have any other method to simplify that? Of course we have some method to simplify. Actually, just like that we said before, if we are using distributive law inversely, can we get 2L plus 2W? Yeah, this is also another expression, and this expression is much easier for you to understand and easier for us to see, to read. So this is exactly the equation that we want. And think about, for equations, what we have used. We use expression on the left-hand side, and use another expression on the right-hand side. And just like we say, if the expression is too long, we can try to simplify that to make that in an easier form. But if you write in this expression, we cannot say that you are wrong. You are still correct, but maybe the formula is not so good to read. This is the only disadvantage. But for the other case, this is still a pretty good equations. So any questions about equation? Equation is pretty easy to understand. If you have an equal relationship between left-hand side and the right-hand side, we can write an expression. We can write an equation. Yeah, this is exactly what I want to say. Okay, so if you have already known the parameter, what about the area? Area. The left-hand side is the area. The right-hand side, I want to use different variables to represent the area. And everybody knows that the area of the rectangle is length times width. So I can also use another expression, L times W, to represent that. And because we have variables, right now we don't need to know what exactly the length and the width it is. We can calculate any combination of length and width. No matter this is an extreme case, no matter this is a special case, or this is just a regular case, because we have the variables. Any questions for this? Okay. Let's see. Okay, if this is a pretty special case, if we are not talking about a rectangle, we are talking about a square. And for the square, everybody know that for the four boundaries, they are exactly the same length. So maybe we can call it A. In this case, if you want to calculate the area, how can we do that? The area equals A times A, the length times the width. But because they are exactly the same, we can also write it A squared. And just like I said, A squared is an expression 2. So this is exactly the equation for the area of a square. Any questions for this? Okay, so let's imagine and let's have a review what we have learned today. Actually today I just introduced the relationship between the expression, equation, and functions. And our purpose for this chapter is to later to understand how to use functions to solve some questions. And also later we will introduce some kind of like display method, like represent method like table lists or rules, and also graphs to help us to understand the functions. And for the fundamental idea of the function, first we need to know what are the expression and equation. So today's class we focus on why we need to learn expression and what expression tell us. And expression is a basic language that is a basic component of the math language in all over the world. If you can write expression, everybody can understand you no matter where he is, what kind of person he is. He will understand exactly what you are talking about. And when you understand the expression, next week we are going to build some equal relationship between the expressions. That's why we build up equations. And later I introduce some questions that we can use equations to write to illustrate, just like the perimeter, there is an equation. The area of the rectangle, there's the equation, and also the area of the square, that is also equation with a little bit complex expressions. Okay, this is all for today's class. If you still have questions, you can ask me right now in the live chat, or later if you want to still have questions but you don't have time to chat with me right now, you can write some comment that after my YouTube account, and later I will try to answer you that with some word, or maybe next time for the next live event I will try to answer your questions. Okay, see you next time. Bye.